Welcome back to ECE 320A. We're in Unit 12, which is our two-port parameter unit, and there is a homework assignment due at the end of this unit, and we're dealing with material from Chapter 18, and the final exam is coming soon. Today, what I want to do in this video is actually illustrate how you might not have to do a ton of analysis. Let's say you did have a 50 parameter circuit and you're trying to find the Z parameters. Oh boy, now I have to do all of this analysis. Well, maybe we can actually take some measurements on that circuit and from those measurements actually extract or identify the Z parameters or any of these other 6 sets of parameters that we might want to obtain. What we want to do then in this video is illustrate how we can do that for one particular example, or how can we find these two-port parameters from measured data. And let's just look at the Z parameters. These are maybe a little bit more intuitive. It's just Ohm's law, essentially, with 2 currents and 2 voltages, and they are interrelated. Suppose that we now have this complicated circuit, and we now take 2 sets of measurements. One set, we go ahead and just leave the output port or port 2 open circuited. We don't connect anything to the output port, and we find that we have, or we measure then, V sub 1 is 8 millivolts, I sub 1, and these have to be consistent with our definitions associated with the 2-port. I sub 1 going from left to right into the port 1 or input port we measure to be 4 microamps. And then we don't have any current flowing since port 2 is opened in the output port, but we are able to measure a voltage, and let's say that we measure a voltage V sub 2 of minus 8 volts. Then the second set of data that we measure, let's now short port 2. We just wire those 2 terminals at the output port together. So it's now shorted, and now V sub 2 is obviously 0, but we can measure V sub 1 to be 5 volts, I1 is 5 milliamps, and I sub 2 is 250 milliamps. With those 2 sets of data that we've now collected, let's try to identify these 4 parameters that might result from a circuit that has 50 different parameters or elements in it. And we can now consolidate those or aggregate those into these 4 parameters, the Z's, in the Z parameter formulation. Let's now see what we can obtain when we have port 2 open, which is this first set of data that we've collected. If port 2 is opened, then we know that that tells us that there's no current flowing in that port, and because of that, now what can we do? Well, we can work with these equations with I sub 2 equal to 0 and utilizing these parameter or measurements that we've now acquired. And we've acquired a V1, we've acquired an I1, and so we can actually use that very first equation with I sub 2 equal to 0 to identify Z sub 1, 1. With I sub 2 equal to 0, then the first equation says that Z1, 1 we can find as V1 over I1 with I sub 2 equal to 0, and we have those values measured. We have V1 is 8 millivolts, and I sub 1 was 4 microamps. Now we just need to keep track of the exponents or the units. We have 8 times 10 to the minus 3 and 4 times 10 to the minus 6. And we have this 8 and 4. 8 and 4 is 2, and we divide 10 to the minus 6 into 10 to the minus 3, and that actually gives us 1,000. So we now know that Z11 is 2,000 ohms. We can now use the second equation that's connecting our Z parameters, the V sub 2 equation, to find Z21 when I sub 2 is equal to 0. So now doing that, we can find Z sub 21 is the ratio of V sub 2 to I sub 1, again with that port, the output port open, or I sub 2 equal to 0. And if you go through the numbers, this is now minus 8 volts. I sub 1 is the 4 microamps. Again, we have a 2, we have a minus sign, and this is partly due to the way that we've defined I sub 2 flowing from right to left in that particular 2-port. And so we would expect possibly to some negative numbers. But now we have minus 2 times the inverse of 10 to the minus 6, or we now have minus 2 times 10 to the 6, or minus 2 megohms for Z sub 21. Then what happens when I sub 2 is short-circuited? I'm sorry, I sub 2 short-circuited. I'm falling asleep. Keep me awake. Port 2, when we have the output port short-circuited, that now says that V sub 2 is equal to 0. And from that, we might have to combine some of these equations, but let's just see what we can obtain when we have V sub 2 in that second equation set equal to 0. From the second equation, we have V sub 2, and realizing that maybe we already have some of the variables in this formulation identified or already determined. We've shorted that second port. V sub 2 is 0. We just solved for Z21. We have that, and we've measured I1 and I2 in this short-circuited condition. So that now allows us to solve for Z sub 22. Z sub 22 is now equal to minus Z21 I1 over I sub 2. And that, if you go through with the appropriate measured data values and the already computed Z sub 21 value, you will find that that's now Z22 is 4 times 10 to the 4th ohms, or we now have 40 kiloohms for Z sub 22. We only have one more parameter to find, and that we can do to find all of these parameters just from collecting a couple of data sets under 2 different test scenarios, with port 2 open and with port 2 shorted. The last one that we need then is the Z12, and that's sitting inside this V1 equation. And we have V1, I1, and I2 that we've measured in the shorted condition, and we've calculated already Z sub 1. So now if we plug in those numbers, we have 5 is equal to 10 to the 3, that's Z11. I1 in the shorted condition was 5 milliamps. We don't know Z sub 12, but that's what we're trying to find. And then that is multiplied by I sub 2, which is 250 milliamps, or that's just 0.25 amps. If we solve that, well, let's just go ahead. We can collapse those 10 to the 3 and 10 to the minus 3 pretty quickly. And now we have something that we can solve even without a calculator. We now have minus 5 is equal to 1/4 Z sub 12. If we scale both sides or multiply both sides by 4, we now see that Z12 is going to be minus 20. We've now determined the Z parameters in this circuit that we maybe didn't want to analyze. It might have had 50 elements. We took a couple of data sets and extracted or identified the appropriate Z parameters. Z12 was minus 20. Now I have to go back and recall what all of these other parameter values actually were equal to. Z22 was 4 times 10 to the 4th. Z11 was 2,000. And Z21 was minus 2 meg, or minus 2 times 10 to the 6th. That's now available to us in any kind of interconnection structure that we might want, and that's what we'll talk about in the next video.